Good morning, students. Today we are discussing about a very important topic, Beer-Lambert's law. Okay, Beer-Lambert's law. that what is Beer-Lambert's law and what's the equation? Okay, according to Beer-Lambert's law, when a beam of monochromatic radiation passes through a absorbing medium, the intensity of incident radiation decreases. What happens exponentially with an increase in the concentration of the absorbing medium. Okay, what happens in this? According to Beer's law, when a beam of monochromatic radiation means single beam. Single beam is singular radiations means UV visible radiations, UV and IR. That's okay. Radiation passes through an absorbing medium. Absorbing medium means you can take this is the light particles. Okay, this is passes through absorbing medium means this is a coated particle with this absorbing means this particle which absorbs the right radiations. Okay, medium, the intensity of incident radiation decreases. Intensity of incident radiation means this one decreases with an increase in concentration of absorbing medium. When we are absorb the radiations, what happens? Our energy will lose the energy. We are losing the energy. Okay, increase in the concentration of the absorbing medium. Okay, students. First, according to Beer's law, when a beam of monochromatic radiation passes through an absorbing medium means it has one beam which is opposed radiation, monochromatic radiation. So in this monochromatic radiation, what happens is this electromagnetic waves and radiations comes under in presence of this absorbing radiation. What happens is this absorbs this radiation. When it is absorbed radiations, what happens? This energy will lose the energy. Okay, decreases exponentially with an increase in the concentration of absorbing medium. Concentration increase అయింది బట్ అబ్జర్వ్ ఎనర్జీ అనేది డిక్రీజ్ అవుతుంటుంది. సో ఇన్ అదర్ వర్డ్స్, ఫర్ ఎగ్జాంపుల్ we will take a balloon. So balloon, first the type is this one. Okay, this balloon in this type can see it's a thick and very okay, this balloon is thick, okay, and strong, very strong. But in this we can fill air. When we fill air, what happens? This is a bubble, okay, like a ball shape or a volleyball shape. What happens when we are taking any needle or any, this is exploit means failure. So what happens? It is when our surroundings are increases, that energy decreases. When our surroundings are decreases, energy increases. So same like this. When radiation passes through this absorbing medium, what happens? This energy losses, but surface is increases. This was increased, this also. Okay, and in other words, absorbance is directly proportional to the concentration of the absorbing substance. Absorbance means minus absorbance means okay, for example we can take minus di by dt minus di by dc proportional to I, intensity. This is intensity, this is absorptivity. What happens is di by dc equal to ki. This is equation 1. Okay, Beer-Lambert's law, where di by dc means rate of decrease in the intensity of incident light. Okay, minus di by dc means what is rate of decrease in intensity of incident light, okay, with respect to concentration. Okay, so next K means proportionality constant. Okay, rearranging of terms. Next one, rearranging of terms from equation 1. What is equation 1? Minus di by dc equal to ki. What should we in this I term we can take left side and dc term this side. So what happens? Minus di by I equal to k dc. Okay, this is equation number 2. Okay, next one, what should we do? Integration. Okay, integration equation 2 on both the sides. Okay, what happens? Minus di by I equal to k dc. Okay, what happens? Integration of previous class also integration of 1 by t dt means what happens? What is log t? So this also same. Minus integration of 1 by I di means what happens? Minus log I. Okay, students, so what happens? Minus log I equal to kc plus b. This is number equation 3. What happens is this c comes from integration of dc means this integration differential cancel. What happens? C is taken. Next, this is the byproducts. Okay, this is the byproducts. Next one, where b is constant in where b is constant of integration. Okay, so when the concentration of the absorbing substance is 0. Okay, students, when we take when the concentration of the absorbing substance is 0, what happens? There is no absorbance. అంతే కదా, ఏమన్నాడు? when the concentration of the absorbing substance means in balloon, what has concentration of the absorbing substance means that is balloon ఎప్పుడైతే గాలి అంటే ఎయిర్ తీసుకుంటుందో అదేమైంది? ఎప్పుడు అబ్జర్వింగ్ సబ్స్టెన్స్ అనేది 0 అయింది. దేర్ ఇస్ నో అబ్జర్బెన్స్. సో అది ఎప్పుడైతే 0 అయితే అబ్జర్బెన్స్ తీసుకునేది మొత్తం టోటల్గా అబ్జర్బెన్స్ ఏమైతే 0 అయింది. ఓకే, సో దట్ ఈస్ I equal to I1 when concentration 0 అయినప్పుడు. ఓకే, substituting values of I and C in equation 3. Question 3, what should we do? Log IT equal to k into concentration means 0 plus b. So minus log IT equal to b. Okay, this is equation number 4. What should we do? Substitute equation 4 in equation 3. What is b value lo ఇది సబ్స్టిట్యూట్ చేద్దాం. ఏమైంది? minus log I equal to kc minus log IT. What happens? log IT minus log I equal to kc. Okay, this IT take left side and kc same position. Kc in same position. What happens? log A minus B. What happens? log IT by I equal to kc. Okay, this log is a common log. Okay, natural log means ln value. This is total converted into ln. What should happens? ln IT by I equal to kc. Okay, so IT by I equal to e power kc. Okay, దీన్ని మనం ఏం చేస్తామంటే ఇన్వర్స్ చేద్దాం. ఇన్వర్స్ ఇన్ బోత్ సైడ్స్. వాట్ హ్యాపన్స్ ఐ బై ఐటీ అంతే కదా. ఐటీ బై ఐని ఇన్వర్స్ చేస్తే ఏమైంది ఐ బై ఐటీ. అంటే దీన్ని ఏమైంది ఇది ఈ పవర్ మైనస్ కేసీ. ఓకే, సో ఏమైంది అప్పుడు I by IT equal to e power minus kc, or I equal to IT e power minus kc. This is the Beer's equation. Okay, that is total Beer's equation. Okay students, what should we take? First one, minus di by dc proportional to I. So the name is minus di by dc equal to ki. Okay, this is equation 1. What should we do? Next one, so minus di by dt equal to kdc. Okay, this is equation number 2. What should we do? Integration equation to on both sides. Okay, we should integrate on both sides. Okay, what happens in this? Minus di by I. So 1 by I di means what should do? Log I and k c plus t. T bag మనం b తీసుకున్నాం. So next one, what happens where b is a constant integration? So what happens in this? Concentration అనేది 0 అయింది. కాన్సన్ట్రేషన్ 0 అయినప్పుడు I equal to I t తీసుకుంటాం. So what happens when c equal to 0? Substitute the values of I and c in equation 3. In equation 3లో ఈ సబ్స్టిట్యూట్ చేస్తాం. ఏమైంది మైనస్ లాగ్ it equal to k into 0 plus b. So what happens log it equal to b. Okay, this b వాల్యూ వచ్చింది. ఈ b వాల్యూని మళ్ళీ సబ్స్టిట్యూట్ చేయాలి థర్డ్ ఈక్వేషన్ సబ్స్టిట్యూట్ చేస్తాం. మైనస్ లాగ్ ఐ ఈక్వల్ టు కేసీ మైనస్ లాగ్ ఐటీ. సో ఇన్ దిస్ లాగ్ ఐటీని ఏం చేస్తాం మనం లెఫ్ట్ సైడ్ తీసుకెళ్తాం, కేసీని ఇక్కడే ఉంచుతాం. వాట్ హ్యాపన్స్ లాగ్ ఐటీ మైనస్ లాగ్ ఐ ఈక్వల్ టు కేసీ, లాగ్ ఐటీ బై ఐ ఈక్వల్ టు కేసీ. ఓకే, దిస్ ఈజ్ ఈక్వేషన్ 4 ఆర్ అదర్వైజ్. సో వాట్ హ్యాపన్స్ దిస్ లాగ్ని మనం ఏం చేస్తుంటే ఈ లాగ్ని ఇది కామన్ లాగ్ అనమాట. దీన్ని ఏం చేస్తాం న్యాచురల్ లాగ్ కన్వర్ట్ చేస్తాం. ఏం చేసేది ఉండదు. ఈ లాగ్ వాల్యూ బదులు ఏం చేస్తాం అంటే ఎల్ఎన్ వాల్యూని సబ్స్టిట్యూట్ చేస్తాం. ఎల్ఎన్ వాల్యూని సబ్స్టిట్యూట్ చేస్తే ఏమైతే ఎల్ఎన్ ఐటీ బై ఈక్వల్ టు కేసీ. ఇన్ దట్ వాట్ హ్యాపెన్స్ ఇన్ దిస్ ఈ ఎల్ఎన్ని మనం యువతలో పంపిస్తే ఏమైందంటే ఎక్స్పోనెన్షియల్ ఫామ్ అవుతుంది. ఓకే, దిస్ ఎల్ఎన్ని మనం ఎప్పుడైతే లెఫ్ట్ సైడ్ నుంచి రైట్ సైడ్కి పంపిస్తాం అప్పుడు ఏమైందంటే ఈ ఎల్ఎన్ కాస్త ఈ అవుతుంది. సో ఇక్కడ ఉన్న వాల్యూస్ మొత్తం పవర్లోకి వచ్చేస్తాయి. సో ఇదే వస్తుంది ఇక్కడ చూడు ఎల్ఎన్ ఐటీ బై ఐ ఈక్వల్ టు కేసీ. ఈ ఎల్ఎన్ యువతలు తీసుకొస్తే ఏమైంది ఐటీ బై ఐ ఈక్వల్ టు ఈ పవర్ కేసీ. ఓకే, ఇన్వర్టింగ్ బోత్ సైడ్స్. వాట్ ఏమైంది ఇన్వర్స్ చేస్తే ఐటీ బై ఐని ఏమైంది ఇది రివర్స్ చేస్తే ఐ బై ఐటీ అవుతుంది. అంటే దీన్ని ఇన్వర్స్ చేస్తే ఏమైంది 1 by e power కేసీ. సో దీన్ని పైకి పంపిస్తే ఈ పవర్ మైనస్ కేసీ ఇదే కదా. సో ఐ ఈక్వల్ టు ఐటీ ఈ పవర్ మైనస్ కేసీ. సో దిస్ ఈజ్ ద ఈక్వేషన్ ఆఫ్ బీర్స్ లా. నెక్స్ట్ వన్ Lambert's law. We know that Lambert's law. ఏంటిది? According to Lambert's law, the rate of decrease in the intensity of the incident radiation with the thickness of the medium is directly proportional to the intensity of the incident light. Okay, minus di by dt proportional to same. So minus dit by dt equal to ki. So we know that. So this is also same, rate decrease in intensity k proportional to minus di by dt kdt. So what happens minus log I equal to kt plus b. This is same. Next one, substitute the equation 4 in equation 9. What happens minus log I equal to kt plus minus log it. So log it minus log I equal to kt, log it by I equal to kt. Okay, converting common log to natural log. So ln it by I equal to kt. Okay, it by equal to e power kt. So what happens in this ln it by equal to kt. Okay, this ln comes under this it by equal to e power kt. Okay, in this e power kt, inverting the both sides, it by I equal to e power minus kt, I equal to it e power minus kt Lambert's sequence. This is also same, e power kc వస్తుంది, ఇక్కడ kt వస్తుంది. Why? Because in this concentration this is in terms of time. Okay, this is the only difference. Okay, Lambert's equation. Combining equation 5 and 10. 5 equation means Lambert's equation. 10 equation means Beer's equation 5 and Lambert's equation 10. So in this combining, for I equal to it e power minus kct. So what happens it by I equal to e power minus kcr. Okay, inverting both the sides, it by I equal to e power kct. So converting natural log to common log, log it by a equal to kct. What happens? Log it by a equal to 10 power kct. Okay, a equal to act. So a means log it by a equal to a, Beer-Lambert's law. Okay, a equal to absorbance or optical density or extrinsic constant. A means absorptivity, C means concentration, T means path length or thickness. Okay, if the concentration is expressed in moles per liter, then the equation is written as I by I not equal to A. Okay, this is a Beer-Lambert's law. What should we do? You know that I equal to IT. In that I equal to IT, where we do C equal to 0 ratio on the concentration. So substituting values of I and C in equation 3. And then minus log IT equal to K into 0 plus B. Minus log IT equal to B. So substituting the value of B in equation 3, what happens? Minus log I equal to Kc minus log IT. Log IT minus log I equal to Kc. Log IT by equal to Kc. Okay. Converting common log to natural log, what happens? ln it by I equal to Kc. it by I equal to e power Kc. I by it equal to e power minus kc. I equal to it into e power minus kc. Beer's equation. Okay. Lambert's equation means according to Lambert's equation, the rate of decreasing intensity of the incident radiation with the thickness of the medium is directly proportional to the intensity of the incident light. Okay. In that minus di by dt proportional to minus dit by it equal to ki. Okay. Where minus di by dt rate of decreasing intensity of incident light with respect to thickness. Okay. Rate of decreasing intensity of incident light with respect to thickness, K proportional to constant. Minus di by I equal to k dt. Integrating equation 8 on both sides. Minus di by I equal to k dt. So minus log I equal to kt plus b. Okay. Integrating equation 8 on both sides, what happens? Minus integration di by I equal to k dt. Minus log I equal to kt plus b. So substituting the equation 4 to equation 9, what happens? Minus log I equal to kt plus minus log it. So log it minus log I equal to kt. Log it by I equal to kt. Okay. Converting common log to natural log. ln it by I equal to kt. it by I equal to e power kt. Okay. Converting both sides, what happens? it by I equal to e power minus kt. I equal to it e power minus kt. This is the Lambert's equation. From equation 5 and 10, what happens in this? I equal to it e power minus kt ct. it by I equal to e power minus kct. Inverting both sides, what happens? it by equal to e power kct. So converting natural log to common log, what happens? Log it by equal to kct. Okay. This is it by equal to 10 power kct. Okay. What happens in this? it by equal to 10 act. Okay. A equal to k into 0.4343. Okay. This is take log on both sides. What happens? Log it by equal to act. Okay. A equal to act. Log it by equal to a, Beer-Lambert's law. Okay. Absorbance or optical density and extinction quotient. What happens? Absorbability and concentration, path length or thickness. Okay. If the concentration expression, we know that. Okay. This is a Beer-Lambert's law. Total Beer-Lambert's law. Okay. This is most important and easy. So students, this Beer-Lambert's law, we can take that. I equal to it, C equal to 0. This is one of the important. From where we taken is very important. Okay. This is the Beer's law. I equal to it. Okay, we should remember I equal to it e power minus kc. This is the Beer's equation. Now this is I equal to I naught. I equal to it e power minus kt. This is Lambert's equation. Okay. This is the Lambert's equation. These two are combined with form of Beer-Lambert's law. This is the Beer-Lambert's law. This is most important, student, in exam point of view also. Okay. So their shape is rectangular, cylindrical, and material of construction varies depending on the instrument and the nature of the sample being analyzed. Okay. For example, cuvettes made of squash are used in UV spectrophotometer. Okay. Cuvettes made of squash are used in UV spectrophotometer, while those of glass are used. Okay. In visible spectrophotometers, the path length, thickness, or internal distance of the cell is normally 1 centimeter. So, however, cells with a longer path lengths up to 10 centimeters, shorter path lengths of 1 to 2 millimeters are also available. Before taking the measurements, sample cells should be thoroughly cleaned to avoid any contamination. The level of the sample solution must be up to the mark etched on its surface or above the light beam to avoid reflections from upper surface of the liquid. An ideal sample cell should fulfill the following conditions. The material used in the construction of a sample cell should not react chemically inert with the solvent it is holding. It must transmit light of the required wavelength. It should have uniform thickness. The surface facing the incident beam should be optically flat. Okay. First we discuss about sample cells or cuvettes are used to hold sample solutions. Their shape and material of construction varies depending on the instrument and the nature of the sample being analyzed. Okay. For example, cuvettes made of quartz are used in UV spectrophotometer, while those of glass are used in visible spectrometer. Okay. Cuvettes made of quartz. Okay, quartz means we can where we get taken quartz for glass industries. Quartz we can take in. Okay. So the path length of the cell is normally 1 centimeter. However, cells with longer path lengths up to 10 centimeter or shorter path lengths up to 1 to 2 centimeters. Okay, millimeters are also available. Before taking the measurements, sample cells should be thoroughly cleaned to avoid any contamination. The level of the sample solution must be up to mark etched on its surface or above the light beam to avoid reflections from the upper surface of the liquid. An ideal sample cell should fulfill the following condition. The material used in the construction of a sample cell should not react with the solvent it is holding. Okay, it must transmit light of the required wavelength. Okay, light of the required wavelength. Okay, next it should have uniform thickness. Okay, it should have uniform thickness. What is it? Reaction complete. The where it reaction taking that side thickness is happen. The surface facing the incident beam should be optically flat. Okay, this is a rectangular cell. This rectangular cell in that chemical reaction do in this cuvette cylindrical cell. This is a cylindrical cell. Okay, these two both are used in a lab, but this is more useful than this because this is used sodium metal also. This is used in that sodium metal taken and in front of flame we can kept so that sodium extraction flame test when we do flame test so this sample cells are used. Okay, amplitude defined as the height of the crest or depth of the trough of a wave. The intensity of the light is determined by amplitude. Okay. Okay, students. Next one, we'll discuss about sampling techniques in IR spectrophotometry. Okay, spectroscopy. Sampling techniques in IR spectroscopy. Sampling handling system. IR spectroscopy helps in the identification and determination of solids, liquids, and gases. Okay, what's the use of IR spectroscopy? Determination of and identification of solids, liquids, and gases. Narrow sample cells. made up of NaCl, KBr, TH, thorium bromide are used. Silver chloride cells are used for aqueous and moist samples. Okay. Polyethylene cells can be used with when absorption frequency is less than 600 centimeter inverse. Okay, polyethylene cells, where we can use polyethylene cells means absorption frequency is less than 600 centimeters. ఓకే, అబ్జర్ప్షన్ ఫ్రీక్వెన్సీ అనేది లెస్ దెన్ తక్కువగా ఉన్నప్పుడు 600 కంటే తక్కువ ఉన్నప్పుడు దాన్ని సిల్వర్ పాలిథిన్ సెల్స్ని యూజ్ చేస్తాం. అంతవరకు కూడా శాంపుల్ సెల్స్ని యూజ్ చేసుకోవచ్చు. IR spectrum varies with the physical state of the sample. Okay, IR spectrum varies physical state. Okay, it is therefore mandatory to indicate the state of the sample in the IR spectra. Example, IR spectra of stearic acid in solution shows broad peaks, making it difficult to characterize them, whereas IR spectra of stearic acid in solid film shows definite peaks. Solid samples can be analyzed using IR spectroscopy by the following ways. Okay, first one, solution of solid. Okay, in this technique the solid sample is dissolved in an inert solvent and the solution is analyzed in a liquid sample cell. Okay, in this technique, solution of solid. Okay, first one, solution of solid technique. In this technique the solid sample is dissolved in an inert solvent. Okay, and the solution is analyzed in liquid sample cell. Okay, solution where solution is analyzed in liquid sample cell. Some of the solvents which are used in IR are CCl4, carbon tetrachloride, methyl trichloride, and ketone, ethyl ketone, cyclohexane, etc. to avoid absorption band due to single solvent. Okay, this is the only single solvent. Two solvents having complementary absorption regions are used. Okay, example CCl4 and CS4. Okay, in that disadvantage is also there. Solid sample may react with the solvent resulting in undesirable product. Okay, undesirable product. This method cannot be used for all solids because suitable solvents are limited and there is no single solvent which is transparent in the entire IR region. Okay, next one, sample film. In this technique an amorphous solid sample is dissolved in a suitable volatile solvent. A drop of this solution is placed in an NaCl or KBr sample cells. The solvent is evaporated by gentle heating which leaves a thin film on the surface of the cell. Okay, the result the film is used for qualitative analysis. Mull method. What is Mull method? Also important. In this technique a thick paste of finely powdered sample and mineral oil, nozzle oil, usual means I don't know also, in sandwich between two salt plates. Okay, thick paste of finely powdered sample. Okay, paste of finely powdered sample and mineral oil. Okay, is sandwiched between two salt plates, NaBr and potassium bromide. Mineral oil widely used in nozzle oil, but it shows absorption maximum to 2915 centimeters. Okay, next one, 1462 centimeter inverse, 1376 centimeter inverse, and the 790 centimeter, which interferes with the sample absorbance. Okay, it absorbance in sample absorbance. This interference can be avoided using hexachlorobutadiene. Okay, you know that hexachlorobutadiene. Hexa means 6 carbons, chlorobutadiene, butadiene means 4 carbons which is in double bond. So with the nozzle oil which absorbs in the regions of 630, 615, 10, 200, 1140 into 1010, 1010, 760 centimeters. This permitting the recording of IR spectra of only the sample. This method is applicable for qualitative analysis of crystalline compounds. This is the sampling techniques in IR spectroscopy. Okay students, first one, sample handling system. Okay, we are discussed. And next one, solid samples. In the solid samples can be analyzed using IR spectroscopy by the following ways. Okay, solution of solid, we know that, and disadvantages, sample film, and Mull method. In this Mull method, a thick paste of finely powdered sample and mineral of oil. Mineral oil means nozzle oil is sandwiched between two salt plates. NaBr, sodium bromide and potassium bromide. Mineral oil widely used in nasal oil, but it shows absorption maximum 1950 and 1462. These all are which is interfere with the sample observance. Okay, in this the recording of aspect of only the sample. This method is applied for qualitative analysis of the crystalline compound. Okay, students. So next one, principle and sources of radiation in a spectrophotometer. Next one, spectrophotometer. In that principle, on this previous class we have discussed about. In that radiation sources we are discussing incandescent lamp. Okay, incandescent lamp anamata. This is incandescent lamp consists of a closely wounded nichrome coil. Nichrome means this is atom which is present in groups. Okay, incandescent lamp consists of closely wounded nichrome oil enclosed in a glass covering. Okay, this is a glass covering. Upon heating, a black oxide film is formed. Black oxide film is formed on the nichrome coil, which gives acceptable emissions of IR radiance. Okay, which gives acceptable emissions of IR radiation. The intensity of IR radiation emitted is less compared to others. Okay, IR infrared rays is intensity is less compared to other radiations. It cannot give far IR radiance and it has low spectral emissions. It does not give far IR radiance. Far means lengthily IR radiations, and it has low spectral limitations. Okay. Next one, near-nest glower. Okay. Next one, near-nest glower means this near-nest glower consists of a hollow rod made up of fusion mixture of rare earth metal oxides like thoria, yttria, and zirconia. It remains non-conducting at room temperature and it should be heated. Okay, non-conducting at room temperature and it should be heated by suitable external measures. External means to make it conductive in nature. Okay, to make it conductive in nature. The energy output for near-nest glower ranges in between 1 to 10 amperes with increases above 10 amperes. Okay. First one, incandescent lamp. Incandescent lamp consists of closely wounded nichrome coil. Okay, nichrome coil means it is also there in where nichrome sheet is there in lab. That is a nichrome coil. So enclosed in a glass covering. Okay, that is glass covering. Upon heating, a black oxide film is formed. Okay, black oxide film is formed on the nichrome coil, which gives acceptable emissions of IR radiations. The intensity of IR radiance emitted is less compared to others. Okay, it cannot give for IR radiance and has low spectral emission. Okay, next one, near-nest glower. Near-nest glower consists of a hollow rod made up of fusion mixture of rare earth metal oxides like thoria, yttria, and zirconia. Okay, next three are new invented elements. So it's not important for other. So it remains non-conducting at room temperature and should be heated between 1000 to 1800 degrees Celsius. In our lab only 500-800 degrees Celsius. This is 1000 to 1800 degrees Celsius. By suitable external means to make it conductive in nature. Okay, the energy output from near-nest glower ranges in between 1 to 10 amperes, which decreases about 10. Advantages. The intensity of radiation emitted is 3 times more than that of incandescent lamp and global source. Okay, what is this? The intensity of radiations. Okay, the intensity of radiation emitted is 3 times more than that of incandescent lamp. Okay, 3 times more than. Okay, 3 times more than that of incandescent lamp and global source. Next one, it emits wide range of radiations. Okay, wide range means different ranges. Okay, without any fluctuations in intensity or prolonged period of time. It does not get oxidized by air. Okay, it does not get oxidized by air. Okay, next one, disadvantages. So disadvantages means it is extremely fragile. Okay, Fragile means it is heating upon very dangerously. Next one, it requires heaters for preliminary heating. It requires frequent repairs. Okay. Uh, Next one, global source. Global source means it consists of a silicon carbide rod about 50 mm long and 6 to 8 mm in diameter. Okay. Silicon carbide rod, we know that very well. Silicon carbide rod means we can kept in houses also, that concrete works. So that is silicon carbide rod about 50 mm long and 6 to 8 mm in diameter. It can be operated to a temperature of about 1300 degrees Celsius. Okay. That radiation emitted by global source is equivalent to 80% of a black body radiation. So we know that black body radiation. Okay, students. In first year also we are discussed black body radiation. Its intensity of radiation is less below 100 nanometers but high above 50 nanometers. Okay, it is less below 10 nanometers but high above 15 nanometers. Disadvantages: it undergoes extraction with time, that is its resistance increases. This can be overcome by increasing the voltage. It is less intense than nearest glower. Okay, this is less intense than nearest glower. First one nearest and second one glower source. So next one, high pressure mercury arc. For radiations in far higher region, high pressure mercury arc is used, which consists of a double jacketed quartz lamp filled with mercury vapor under high pressure. It is shorter wavelengths. The heated quartz jacket gives out intense radiation equivalent to that of black body sources. Okay. This first one, incandescent lamp. Okay, incandescent lamp consists of closely wounded nichrome coil enclosed in a glass covering. Okay, we know that closely enclosed nichrome coil. Okay, upon heating, a black oxide film is formed on the nichrome oil, which gives acceptable emissions of higher radiation. The intensity of higher radiation emitted is less compared to others. Okay, intensity of higher radiation less compared to others. This intensity is less compared to other radiations. It cannot give for higher radiations and has low spectral emissions. Nearest glower. Nearest glower consists of a hollow rod made up of fused mixture of rare earth metal oxides like thoria, yttria, and zirconia. It remains non-conducting at room temperature. Okay, it remains non-conducting at room temperature and it should be heated between 1000 to 1800 degrees Celsius by suitable external means to make it conductive in nature. Okay, to make it conductive in nature. The energy output from nearest glower range is in between 1 to 10 nanometer, which microns, 1 to 10 microns, which decreases about 10 microns. So advantages means the intensity of radiation emitted is 3 times more than that of incandescent lamp and global source. It emits wide range of radiations without any fluctuations. Okay, wide range of radiations it emits, but without any fluctuations in intensity over prolonged period of time. It does not get oxidized by air. Disadvantages means it is extremely fragile. It requires heaters for preliminary heating. It requires frequent repairs. Global source. It consists of a silicon carbide rod about 50 mm long and 6 to 8 mm in diameter. It can be operated to a temperature of about 1300 degrees Celsius. So, student, 1300 degrees Celsius. The radiations emitted by global source is equivalent to 80% of a black body radiation. Its intensity of radiation is less below 10 micrometers but high above 15 micrometers. What is disadvantages? It undergoes exhaustion with the time, that is its resistance increases. This can be overcome by increasing the voltage. It is less intense than nearest glower. Okay. Next one, high pressure mercury arc. For radiations in far higher region, high pressure mercury arc is used, which consists of a double mercury arc is used. It consists of a double jacketed quartz lamp filled with mercury vapor. Under high pressure, at shorter wavelengths, The heated quartz jacket gives out intense radiations equivalent to that of black bodied sources. Okay, that is the hypersymmetry arc. Okay, students, next one, sample holders. What is sample holders? That is sources, principal sources, radiations in spectrophotometer. This is sample holders. Sample holders are cuvettes are used to hold sample solutions. Okay, sample holders means we are seen in lab. So these sample cells or cuvettes are used to hold sample solutions. Their shape rectangular cylindrical. This is a whole cylindrical cell. This is a rectangular cell. Okay, in lab also there. So the shape